Lesson 6, Naming Ionic Compounds. The IUPAC is the International Union of Pure and Applied Chemists. They were the ones that created the naming system. Naming ionic compounds, you first need to name the metal, which is the positive ion, first. You will write the symbol of the negative element, which is typically nonmetal, and change the ending to "ide." If a polyatomic is used, you will use the name that is listed on Table E in your reference packet. So for example, Li is lithium and bromine, so the bromine becomes bromide. So for example, with a polyatomic ion, Na2SO4, Na is sodium, SO4 you will see is over here, and this is sulfate. So we end up with sodium sulfate. If more than one oxidation state, in other words our transition metals, you need to determine the charge of the metal based on the ion. In other words, you need to reverse the crisscross method we learned in Lesson 5. Indicate the oxidation state of the metal ion with a Roman numeral, and then you will place the Roman numeral in parentheses after the metal ion. So, for example, if we have copper chloride, you will notice that copper has a possible oxidation state of a 2 plus and a 1 plus. So if we were to reverse the subscripts, we would end up with chlorine with a -1 and a copper with a 2 plus. So when we write it out, we have copper 2 chloride. This Roman numeral 2, tells us what charge copper has. This is very important when we're working with any element such as our transition metals that have more than one possible oxidation state. So we'll practice with K2O. Potassium does not have more than one oxidation number, so it is just potassium oxide. The oxygen changes to oxide, indicating that it is bonded. Another one is CaBr2. Ca is calcium, and Br is bromine, and since it is bonded, we change it to bromide. So here we have CoCl3. CO has more than one possible oxidation number, so we need to determine which one we need to use. So if we were reverse, here we have a 1, so chlorine is a -1. Our cobalt would then be a 3 plus. So when we write this, it's cobalt 3 chloride. So let's check our understanding. Name the following substance. So here we have ammonium, and ammonium is a polyatomic ion, so we do not touch this, and we end up with ammonium chloride. Here we have zinc oxide and iron 2 chloride. So now we're going to write their formulas. Zinc is a +2 ion, oxygen is a -2 ion, so to put them together we just end up with ZnNO. Iron 2 means that the iron has a +2 charge, chlorine is a -1. When we place them together, we cross the numbers and end up with Fe1Cl2. So, calcium oxide has a Ca with the 2 plus, oxygen with the 2 minus. We'll write the oxidation numbers and then we will crisscross them. And here we end up with Ca2O2, but from here we need to simplify. And we end up with CaO.